have two practices. One is about design, one is about fabrication. And I thought it was important that both be united or done in parallel, because I think architects might have a tendency to design in abstraction from materiality or from the contracting or from the actual objects that come out. And I think our goal is to reconnect things and create a more holistic architecture that work in relation to the circular economy. So looping it back. So this is about future living, future working, future shopping, et cetera, et cetera. So I'll try my best. And I don't know, you might have heard of us through what we did at Burning Man. I don't know if any of you have gone there. Burning Man is a city of the future, really, an experimental city that where 70,000 people come together around common values, common principles, which I'll explain a little bit more. And I think it will be interesting to see that together as part of exploring future cities beyond living and working just in general. Something that I find really interesting about that place is that it creates communities, communities that try and improve and change things. In fact, there is the founder of Burning Man that says that real communities grow out of a shared confrontation with survival. They're produced through shared struggle. And it's really kind of interesting to see how that shared struggle creates pockets of initiatives, which eventually kind of change the world. And I think there's very much that shared struggle around the idea of climate change that I think we're all trying to address through our different fields. And there's another thing that I thought is really interesting. I don't know if you've read the book by Harari called Sapiens, where he says that maybe humans switched from being hunter-gatherers to, civilization and crops, not because they wanted to do increased productivity, but because they wanted to build and run temples. And I thought that's really interesting, because our spiritual self is maybe what united us. And so beyond functionality, I know modernism was all about functionalism and so on, but maybe there is a higher dimension that unites us. And maybe that's something a bit more subtle that we'll discover together. And maybe that's what, also might differentiate a pure technical approach to a slightly higher level one. So those are our two businesses that work hand in hand. This is our studio in London. So we tend to produce things in our office. We're a bit of a mini factory. Beyond, I'm very inspired by people like Jean Prouvé. I don't know if you know him. He was a French engineer type that also had his factory in his office kind of thing, and that allows to produce the thing rather than representation of the things, which I think is really important when you come to understanding carbon footprint. So this is our giant printer. It's about 3 meters. It's a WASP 3MT. We have 2 of those. We have quite a few smaller ones that help us test what things like a shell behavior, and then we crush things. And then we reuse the material. And so this allows us to sort of not be fearful of creating. I think when it comes to environmental design, the answer is always nothing is better than something, because if you just measure carbon, you might as well not exist. And so I think it's really important that we enable creativity without that sort of self-shame in a way. And so to create ecosystems where we can recycle, where we can use materials that don't come from petroleum is really important. So this is called PLA, polylactic acid, and it's basically a material that comes from sugar. And we've done what's called an LCA, life cycle assessment, to compare these materials, petroleum-based plastic being ABS in blue, and in green, a sugar-based PLA. Fermented sugar, in fact. And so you can see that it's pretty much better everywhere, apart from a few things like land use and radiation, like ionizing radiation. This one I don't know, but the land use one we could address through vertical farms. So there's a lot to understand when you compare things in terms of environmental aspects. And I think it's really important to understand that things are not just in one dimension. When you say something is bad or something is worst, it's very binary. But actually, when it comes to environmental design, there's many access to consider, and so that's what life cycle assessments can do. So this is a sort of larger speculation of what the the future of living could be, which is a sort of giant skyscraper that not only can build itself but also unbuilds itself. Now, I think this idea of unbuilding is completely overlooked. And it's actually really natural, when a plant doesn't have enough light, enough water, it just dies, and another plant sort of grows somewhere else, and the natural cycle enables that freedom. But when it comes to architecture, you're suddenly stuck with ruins for thousands of years, if you're lucky and you're the Parthenon. But most generally, people don't think of afterlife of building. Now, I've pretty much been inspired by Burning Man because you have to think of this afterlife, because you have to leave no trace. And so bringing this idea of ecological thinking to parametric design is why, I guess this term eco-parametric came about, because often we think of technology for its own sake versus in relation to natural behaviors. So this is, for example, some student project that we worked on. This was bamboo being folded according to magnetic fields, with the center of the magnetic points being natural. And this was a sort of piazza that used this steam bent timber. And this was a slightly more conventional project, but looking at the typical module size of a building. So to use off-the-shelf material, but to actually use this as a voxel and being able to dissolve this timber to create kind of a system rather than a form. I think this notion of system versus form is really important, because then you stop thinking in a top-down fashion and more in a bottom-up way. And so in that spirit, this is a project we're doing in Bacalar in Mexico. And basically we based it on the bending radius of timber. And if you were to unfold these things, they would all unfold into straight lines. And that's a really important concept, because before, when I was studying digital architecture, we were told, you could CNC everything. But when you CNC things, you create a lot of waste. You use plywood, which is already a processed material, and then you cut it and then you create waste. Whereas these are all bent digitally into straight elements. And so you actually use timber, the tree, straight out of what it is. I think when you minimize chemical processes, you actually can also help the life cycle assessment of materials. And yeah, so same, when you say I'm using wood, it might not be enough. You might need to dig into what wood, where did it come from, which forest did it come from. And so in this case, we're building a tower in Bali, and the client bought an old bridge, which is interesting. It's a colonial bridge from Indonesia, from a Dutch colonial bridge. He bought it and then took off all the timber, removed all the screws, and then built the tower on the left. And I think that's a really interesting, beautiful thing, that we don't have to actually think of projects as their end goal. You can think of your project will become someone else's project later on. And that spirit is a bit strange for architects, because we have big egos. As you know, we're known for this kind of character. And I think that's really something that needs to change in order for our profession to progress towards accepting things as systems that are beyond us. And so these are, I'm going to show you a few projects. This is where we started a lot of made projects that we made ourselves as opposed to just designed. So this is the wooden wave, and the previous one was a fashion retail experience. And so these are kind of based on double curving materials with lattice hinge, with origamis. They're very kind of modular, in that it's one module that adapts through the compression and expansion of what we call Bézier splines. Bézier splines are what, there's a French engineer that worked in a car manufacturer that just had to describe the curvature of cars through an algorithm. And we use that algorithm to bend and expand space. And it's become a bit of a thing where we try and then link that to the lines and extract information for the robots. So this is called G-code. It's the information you send to a 3D printer. And it's important to understand what it is that you send to a printer, because then you are completely free of constraint. And so that means you can be a lot more accurate in the way that you design three-dimensional things. because you are in direct discussion with the craftsman, in this case, the robot. But there is a conversation, although it's a robot, that is important to have, because otherwise you cannot be very, very precise in your analysis of how things are made. So we've taken crazy challenges and keep doing so. I think for some reason, every one of those challenges pushes us to think differently. This, for example, was an installation for Fortnum and Mason in London. And the curvature that you're seeing allows us to build very thin shells. And very thin shells are important because you use less material. So not only do we use sugar, fermented sugar, but we try and minimize the amount of material in order to, and so people were very surprised how light these objects were. And because they're light, it means we use less material, and everything has a sort of consequence. Nice thing is we can like mix it with wood, create like patterning that is a bit more, let's just say, less mass produced to some extent, which means that this is my home in Stoke Newington that we're about to finish, and I kind of look forward to showing you all how it looks. But basically, this has a lot of materials that were not petroleum based, and it's very hard to find them for the home. Whether it's the fermented sugar of the balustrade, the clay, we're using clay everywhere, clay boards, clay finishes, recycled glass, and so on and so forth. Keboni wood for the facade. Keboni is a pine that's treated so that it's not like a teak. It's a very common tree that's just added a resin to. And so it's a lot of learning curve, and there's no limit in the scale, which, I put this because I thought living, this is with my wife's engagement ring. And I show this because I worked on it in a similar way that I work with the rest of the project, and that shows that I really mean it. This was 3D printed, and then the white gold was then casted into what's called lost wax. So the prints was replaced with the gold, and the sapphires were scanned and introduced in there. This is a chandelier we're doing in the north of the UK in Scotland. Which is 3D printed in a mixture of fireproof material together with bioplastic and metal. So those are things that we can explore. We kind of proved to some extent that we can scale up slowly. I mean, it's getting there. We're approaching the facade world now. This was for Cost, a fashion brand. It's called Conifera. And it was a project made of 700 of these bio bricks that were placed together in order to form this sort of journey, as opposed to a form. It wasn't quite a form. It was more of a journey that went from the earthly to the sky. And you can see these, they almost look like they were hand woven, which is quite interesting. When it comes to 3D printing, you can really minimize materiality. This direction was against the arches, which means that we actually could maximize tension in the system as opposed to compression. This here was a project we did with Chris Brecht, in a great architect from Austria. It was 3D printed in sand. We started from kind of looking at that space and play with the trees that were there, and developed this module that we later on realized we could print with local material, i.e. sand, which was really, and you can see here the biophilic link. Biophilia just means like the love for nature and the understanding of nature and being part of it. And you can see each one of those lines changing in thickness based on the forces going through the system. All right, 14 minutes. I have 6 minutes, and I want to bring you a little bit more in the desert. Bear with me. This is Burning Man. Burning Man has 10 principles that I think are really important for the future of living, whether it's radical inclusion, or self-reliance, self-expression, communal effort. I mean, you can recognize a lot of the discussions that are happening at the moment about inclusion and sort of environmental discussions in the principle of Burning Man, which is why I find it so interesting. It's also heavily inspired by the Californian ideology and things like Buckminster Fuller, idea about how we all are part of a spaceship Earth, and that we all need to consider everything as an integral, holistic system rather than separated elements. So I showed you that, and I think this is a city. It's a city of 70,000 people that unite for a week and create and then unbuild itself and then recreate itself, where everyone is a bit of an actor of the city rather than just a spectator, so an artist. So instead of doing art about the state of society, we do art that creates society around it, is what Larry Harvey, the founder, was saying. So with our students at Westminster, we've been trying to experiment of what that means. And this is, for example, a piece of ply that's cut in half and then creating this reciprocal structure that leads to projects that kind of are simple to build and simple to assemble and are based on wasteless designs. These are some of the examples of what we've built and things that we've learned, from the very, very complex parametric digital stuff to the more simple 2x4 pieces of wood that are assembled together. We've learned a lot. We've learned on transportation. This is a truck with the project that was on the right, and then the project that was on the left was sort of placed messily in the truck. And I remember the truck driver telling us that the truck is probably one of the most important designers in the structure, the truck itself. And you see, when I talked about the robot having a discussion with a robot, you can have a discussion with your truck as well, or with your plane, or with your shipping elements. And I think that's really something we ignore. It's the logistics, and the logistics are key to the building being actually green or not. So this is on the right, the bismuth bivouac, and then on the left, the project we never finished. That was a very complex puzzle. We've learned a lot from off-the-shelf timber, so how wood comes out, and then how it can be cut simply, and how we can create structures that follow mathematical rules. I just want to show you this little video of the LEDs going through these tangents. And you can see on the right, people writing down their dreams. And so there was a really nice dialogue with the community, which we thought was really interesting. This is the temple at Burning Man. So every year Burning Man has a temple where people can write things on the structure. And it's often quite emotional things. And at the time I was working on a hotel for Virgin Galactic, which is, going to space and doing space tourism. At the time they needed a hotel before going to space. And this idea of sort of recursive galaxy came about. So this is very simple. It's a recursion in the computer. You tell information to a vector. You say it to move, rotate, on and on and on and on. But as you do this, you can change the parameters, the angle, the length, and so on. And so what I find interesting is when you start linking this with environmental design, for example, letting the light go through in winter and diffusing it in summer, but also just looking at the thermal mass of things, like how we can actually use the cold air to minimize, for example, air conditioning. Air conditioning is about 10 times worse than CO2. So we can work with all these aspects to think of the structure as a system. So Galaxia was a sort of reinterpretation of that building in the desert. And it was based on, again, compression and expansion of space. You can see the center of Galaxia being a lot denser than the rest. It's because it's based on the black hole idea that it would compress and take everything with it. So it starts with portals for humans and then goes through. And so what's interesting is how people were using that project as a secular temple. And so everyone, saw the sort of metaphorical aspect of every piece. There's no columns, so everything seems to float and everything is working together as opposed to in a hierarchical fashion. And so you can see how it was built with a big bike wheel in the center that held everything together, because we couldn't build foundations, for example. Each one of those modules were assembled into these bricks as well, similar to the Conifera project. But these bricks were assembled in timber with laser cut metal connections that were actually targeted towards the forces going through the project. And we were all together, 120 volunteers building this, living together, building this for about 18 days. And built from the top down. So built from the very top to give a positive spirit to the team, because it was hard. It was very hard. It was very intense. And so we built this from the top down, which I think is quite interesting. And then we opened it to the public and had these really beautiful, altars and messages. And I got married in there. Remember the ring? So I just thought it was really nice to, I would talk about the future of living the spaces that you work on and being able to transform what happens inside into something that I can relate to and that others can relate to. And so it was a really beautiful event. And after a week of it, we all sat down together and set it on fire. It's not ideal. Obviously, don't want people to burn buildings, but what was there, it was a ritual of letting go. And this notion of letting go and actually just removing everything in order for it to start again the next year is something I find quite beautiful. I mean, I think none of us are here forever. And so the idea of afterlife of the building and what could happen is I find really interesting. So this summer, what our plan is to build this and disassemble it. This is called Catharsis. It's based on a mathematical geometry, and reassemble it in London, and then have a dialogue between cities where we can actually bring a project in two different places and actually have people dialogue through architecture in cities. So I'll finish here. Obviously all this is very digital, but I think anyone can access that kind of thinking. These are sketches that I work on to just show how these relationships could also be hand-drawn, and it's really a way of thinking that is beyond just the technology. And so I'll leave it there, and I think it's been 21 minutes, so not too bad. And yeah, happy to take it to the breakout room. Thank you everyone for staying here.